Swapping the scaffold around an AI model can swing its performance by an incredible 22 points. Meanwhile, changing the actual frontier model itself, that only moves the needle by a single point. That massive 22-point swing on the SWE-bench Pro benchmark proves a really stark reality. The scaffolding, not the raw language model, is the true driver of modern AI capabilities. So let's look at exactly why that is.
Section 1. The true driver of AI.
We really need to shatter this illusion that the underlying AI model is doing all the heavy lifting when you run an autonomous task. It's a super common misconception, but the data from mid-2026 tells a completely different story. Look, a bare language model is just an engine that outputs text. It's a text predictor. It has no memory, no hands, and absolutely no eyes on your files. An AI harness, on the other hand, acts as the rest of the car. It's the transmission, the steering, the brakes, the stuff you actually need to execute autonomous work safely. Without a harness, that shiny Formula One engine is literally just sitting on the workshop floor, making a lot of noise but going absolutely nowhere.
Section 2. Under the agent's hood.
To understand how this tech actually works for a sharp builder, we've got to look at the execution loop. This is where the magic of autonomy really happens. The harness runs this relentless cycle. It thinks and reasons, it acts by triggering a tool, it observes the result, and then it repeats until the whole task is done. It basically forces the model to actually look at the result of its actions. So if a test fails, the harness feeds that failure right back into the think stage, so the model can try again.
And the best part is, builders can completely customize this exact loop. They're adding custom tools through the Model Context Protocol, or MCP. They're spinning up isolated sub-agents to handle parallel tasks without confusing the main thread. They write these highly specific system prompts to enforce roles, and they set up lifecycle hooks that automatically trigger actions right before or after a tool runs. Now, because the raw model can only see a fixed window of text, advanced harnesses use something called context compaction. Basically, they progressively load tools only when they're actually needed. This incredibly smart context management saves a staggering 98.7% on token overhead. That keeps the model from just drowning in unnecessary tool definitions.
Section 3. Clearing up the terminology.
Okay, the industry is just swimming in confusing jargon right now. You've probably heard a million different terms and asked yourself, are they all just the same thing? Like, is an AI harness the exact same thing as an agent harness, or an agent framework, or a scaffold, or an evaluation harness?
Let's answer that directly. Yes, an AI harness and an agent harness are the exact same thing. They represent the complete, opinionated software enclosure, the execution loop, the tools, the context, the memory that actually turns a stateless model into a capable, functioning agent.
However, a harness is fundamentally different from an agent framework. An agent framework is just the building materials and the toolkit. Think things like LangChain or Crew AI, which developers use to build the harness itself. The framework is your library of parts, but the harness is the fully assembled car.
It's also completely distinct from a scaffold. A scaffold is specifically the temporary harness configuration that researchers use during benchmarking, just to see how a model performs under very specific test conditions.
And finally, an evaluation harness. Something like SWE-bench is strictly the test rig that runs an agent against tasks and scores it. It's the testing infrastructure, right? Not the production system doing the actual work on your laptop or in the cloud.
Section 4. The tools builders actually use.
Looking at the landscape that's really capturing the public's attention in mid-2026, we've got some absolute heavy hitters. You have Cursor, which dominates the Agentic IDE space as the daily driver for devs, pulling in a staggering $2 billion in ARR. Then there's Devin, the autonomous platform that completely proved commercial viability with a massive $25 billion valuation. We also see Claude Code and Codex CLI leading the terminal space, right alongside open-source champions like OpenHands and Aider. Builders flock to these tools for highly specific harness features. For example, they want Claude Code for its terminal hooks and OS-level shell sandboxing. They absolutely love Codex CLI for its background asynchronous pull request workflows. They deploy OpenHands for its strict enterprise-grade Docker isolation, and they rely on Aider for its seamless Git-native code tracking. You see, it's the harness features, not just the model, that win over the users. In fact, by testing minimalist harnesses across different models, researchers found that frontier models inherently understand their roles. What that really means is the underlying language model itself is largely interchangeable.
A genuinely great harness can make a cheaper model perform just like a frontier model.
Section 5. Why the harness wins. This leads us to the absolute most critical realization for anyone building, buying, or investing in AI architecture today. Microsoft's M-Security Harness team completely hit the nail on the head when they concluded, the model is a commodity, the harness is the moat. Because base models are commoditizing and catching up to each other so incredibly fast, the accumulated, governed, and organization-specific harness is your true commercial and functional moat. You invest in the harness because things like context pipelines, verification ladders, externalized memory, and security guardrails, those are going to outlive any single model generation. The model is just an ephemeral engine that you'll eventually swap out, but the harness is the permanent infrastructure that actually understands how your business works. Harnesses, not just the raw models, completely decide what AI can really do next, which leaves us with one critical architectural choice to make for our own workflows. If the models are interchangeable, what will your harness be?